Today's lesson is 2.2, Solving Systems of Equation by Substitution and Elimination. In this first video, I'm only going to talk about substitution. In the next video, I'm going to go ahead and talk about how to solve using elimination. So let's go ahead and get started with substitution. Now, to solve a system of linear equations by using the substitution method, this is actually the best way for our two equations to look. So remember, we always want to label them as equation 1 and equation 2 so that we can look at them and we know what we're talking about. Everybody knows what we're looking at. Now, the first thing we need to do, I really like to use this, this table to help me solve when I'm doing substitution because it tells me exactly what to do step by step. So here we go. The first thing we're going to do is we're going to solve for the single variable. Now, let's go ahead and talk about what a single variable looks like. Well, a single variable would be something like x or y. There's nothing by itself. So a single variable, let me go ahead and put it in the blue that I use. So a single variable would look like x equals or y equals. And this is the best. If you can find x, one of the equations to say x equals or y equals, that is the best for your single variable. That is the best for your single variable. But, well, I can write that better. But 1x or 1y will work, okay? So when I'm looking for a single variable, when I'm looking for my single variable, I'm looking for x equals or y equals. That's what I truly, truly want. Let me go grab my, take a look right here in equation number 1. In equation number 1, I see y equals, and then I see 2x plus 5. So for this one, equation number 1, which says y equals 2x plus 5, is going to be my single variable. This right here is my single variable part, okay? There's no number in front of the y, and it's already been isolated. That is the absolute best single variable that you can get. Now what I'm going to do is I'm going to grab my second equation, and I'm going to put it in this one right here. Oops, hold on. There we go, 3x plus y equals 10. And I'm going to take this part right here, and I'm going to substitute it in for the y right there. So I'm going to take this and I'm going to put it in right here. I'm going to put it right there. So I'm going to say 3x plus, the y is going to open up, and I'm going to say equals 10. The y is going to open up, and I'm going to put in there 2x plus 5. Now, since it was simply y, and I expanded it, right, with the parentheses are not making me do any distributing. They would only make me do distributing if there was a number right here in front of the y, but there's not. So I just have 3x plus 2x plus 5. So I really just have 3x plus 2x plus 5 equals 10. I can go ahead and solve that equation. I can put my x's together, right? 3x plus 2x would be 5x plus 5 equals 10. I'm solving for the variable x. I'm solving for the variable x. It is alone on one side, so I'm going to go ahead and get rid of this addition by doing the opposite, which is, of course, subtracting. What I do to one side, I have to do to the other. I'm going to bring down that 5x. And of course, our last step should almost always be to get rid of the multiplication. We very rarely do division. X equals 1. There's one of my first answers. I'm going to go ahead and circle it. There we go. Now what I'm going to do in my last one is I'm going to find the other variable and I'm going to write the solution. Now it is completely my choice. What I'm going to do is I'm going to take my answer and I'm going to plug it back into one of the two original functions. It's completely my choice. I think I'm going to choose this one though because y is already by itself. So I'm going to come back to equation number 1. And I'm going to say y equals 2x plus 5. But guys, I already know what x equals, so I'm going to substitute that in. 2 times 1 plus 5. Well, 2 times 1 is 2, and 2 plus 5 is 7. There's my other answer, and I'm done with the problem. Sometimes we like to write our solution as an ordered pair, and if we were to do so, we would write it as 1 comma 7 with our parentheses. Let's go ahead and try one more. All right, so solve the system using the substitution method. All right, so we're going to go ahead and call them equation 1 and equation 2. Now we're looking at equation 1 and equation 2, and we're looking for a single variable. I see quite a few. I see x, I see x, I see y. Now some of you might not have thought about this y because it does have the negative 1 in front of it. So let's stick with x or x. I think I kind of like equation number 1 better, simply because there's nothing in front of the y value as well. Now, what I'm going to do here is I'm going to choose to make x be my single variable. So I'm going to come back and I'm going to make these guys black. There we go. I need to get that blue x by itself. I need it to say x equals because that's the best one. Then I can go ahead and I can substitute. It has to be in that form. So I'm going to take my y and I'm going to move it to the other side. Since it is being subtracted from the x, I simply need to add it to get it to the other side. And it's okay, I can leave it in this form, or I could switch it and I could have written it in this form as well. It's fine, okay? All right, so here is my single variable. Look, it says x equals, which means I'm going to take this part here and I'm going to substitute it into the next equation. So we're going to take equation 2, which we can see right there. There it is. And we're going to take this right here and we're going to plug it in for the x. So I'm going to open up that x. I'm going to put my plus 2y equals negative 6. Inside that blue parentheses, I'm going to put my 3 plus y. I'm going to ask myself, do I need to distribute? Do I need to distribute? No, I do not, because there is nothing in front of this x. There's nothing in front of that x. So I simply can go ahead and drop the parentheses, meaning I have this equation to solve. I can solve this equation for the variable y. I'm going to go ahead and I'm going to take my y's and I'm going to add them together. Remember, there's an invisible 1 hiding in front of the y, which gives me 3y. Remember, we're getting y by itself. That's our goal. So we're going to have to get rid of the plus or the minus first. I see plus, it is a positive 3, so to get rid of it, I'm going to go ahead and subtract 3. Be very careful. It is a negative 6, and you're taking away more from it, which will give you a negative 9. Remember, you want to get rid of that multiplication, and so you're going to go ahead and divide. Y is going to equal negative 3. There's our first answer. Now I'm going to take that and I'm going to substitute it back in. I can substitute it into either equation. Okay, so if I scroll back up, I can take my answer and I can put it back in whichever one I choose. Now, I want to choose the one that's going to be the easiest for me to solve. So I'm going to go back and plug it into example 1. Why did I pick this one? Because x and y are both alone and I don't have to do any multiplying. In fact, I'm probably only going to have to do some adding or subtracting, maybe some dividing. So let's go ahead and let's plug it back into equation number 1, which is x minus y equals 3. But I already know that y is negative 3, so I'm going to say x minus, plug it in, equals 3. I'm going to put the negative 3 right here. Well, technically, I don't have to have the parentheses because once again, there's nothing to distribute. So I can think of it as x minus minus 3 equals 3. I can solve this equation. Minus a minus would become a plus. So I'm going to go ahead and to get that x by itself, I'm just simply going to get rid of my plus by subtracting. It cancels on both sides. 3 minus 3 is 0, and there's my second answer. If I have to write it as an ordered pair, I would write it as 0, comma, negative 3.